In this tutorial, you will learn how to create this infinite jumping style of canvas game. Now, there are other videos already on YouTube which focus on creating this similar type of canvas game using the Canvas API like I'm using. However, in my opinion, my version is better than that because I went to the effort to actually give this rotating animation onto the player cube when it jumps into the air, as you can see. This makes the game feel a lot more interactive than the other versions of the game, where the player just jumps up and down statically. Mine actually makes it feel more live. I've also incorporated sound to make things more appealing, and this game over menu which actually animates into existence. And other than that, the game does speed up. So I don't know if you saw back there, but for every multiple of 10, so 10 points, then 20 points after that, the game actually does speed up to make it harder for the user because they've survived for quite a long time. And I think you get the basic idea of this game. It's not too complicated. It's a good beginner project, so maybe if you don't have a lot of canvas experience, then this will be a good project to make. But it does actually challenge you a bit as well, because other people's tutorials not focus on this rotation of the player as it jumps into the air, and it's actually surprisingly difficult to do it. But I think I've spoken enough now. I think it's now time to get on to creating this. To not waste time, I've already set up the starting markup and CSS that I will be using for the rest of the project. Feel free to copy what you see here, or you could customize the base layout to your choosing. So this is the styling, just in case you wanted to see this, along with the HTML. One thing that I will point out, however, is that my canvas is set to be a square of 600 pixels by 600 pixels. If you do deviate from my base template, then it is important to consider that if you size your canvas differently to me, then you will need to be careful when you draw graphics onto the canvas. Because when we get round to using the context, if you copy the offsets that I use, then the graphics will look differently on your canvas because it has been sized differently. So it's just something that you need to keep in mind. And so now that we've got our base styling down and you've copied this styling, or maybe you've made it your own, we will now move on to this empty JavaScript file, which is obviously the main base of this tutorial. Of course, we'll start our JavaScript file by extracting the context from the canvas. Without it, we would be unable to interact with the canvas. Before we continue any further, we will create references to the sound effects that will be used in the finished game. Whilst I may not be using them immediately, it is good practice to get them set up now so that I won't have to fiddle around with them later on. If you want to use the same sounds as me, then a link to these sounds will be posted in the description box below, along with the game's CodePen page. So once we have set up the audio, the first thing that we will get onto creating is this horizontal line here, which you can see in the finished game. We will assign the line to its own function, so that its code can be separated out from the other things that we will also be drawing to the canvas later on. Remember that our canvas was 600 pixels by 600 pixels. This will explain the offsets that I have set to the line. First of all, we move the line to be 0 pixels on the x-axis and 400 pixels on the y-axis. This means that the line will start on the left side of the canvas, but 400 pixels down from the top edge of it as well. From this 400 pixels y offset position, we use this line2 method, which also keeps the y offset of 400 pixels. However, it will have an x offset of 600 pixels, and that will simply draw a horizontal line all the way across the width of the canvas to create that background line we need. To draw this line to the canvas, we will need to create this animate function. It will be repeatedly invoked on each canvas frame. This means that we use this animate function to update our canvas graphics to create the illusion of movement, when in actuality all that is happening is different drawings are being displayed in quick succession, and on each subsequent frame a slight modification is made to the drawing to make it look like it is actually moving. The request animation frame method is built into JavaScript. It is what will get our animate function to be repeatedly invoked on each new canvas frame. Below that, we have written out this clearEct method from the context. Its purpose is to clear out the contents of the previous canvas frame to make way for the new canvas graphics that will soon be created lower down in this animate function. Once all of this prerequisite work has been done, we can now call our background line function to get the same line drawn to the canvas on each new frame. It is important that we don't forget to call this animate function on initial document load. Without doing this, the request animation frame method would not be able to do its magic. So now we should be able to see the canvas line being drawn. However, I don't know if you can see this, but the problem is that it's not a completely black line. It actually looks more grey than black. The reason for this is because the line is currently only set to be 1 pixel wide. Canvas interprets this as 0.5 pixels of black colour on either side of the line. This explains why the line looks grey, when in actuality it is 50% black. To solve this, we will change the line's width to be 1.9 to signify 1.9 pixels on either side, which will hopefully solve that issue because it's not 0.5 pixels on either side now. So now it actually looks black without any increase to its width. Great, so we have successfully created our background, and while it may be simple, it does the job for the purpose of this tutorial. It is now time to add some user interactivity in the form of the black player cube that the user will be able to make jump. It will have its own class, allowing us to abstract methods and fields into this specific class and not the application at large. When we instantiate an object from the player class, we want to be able to customize its position on the X and Y axis and its size and its color. This is why we have created these arguments in the player's constructor and assigned the arguments to the matching fields. The draw method on the player object is invaluable. This is because it is what will get the player class actually rendered to the canvas. To do this, we will need to initialize an instance of the player class. Its Y offset here is 350 pixels because the line is 1 pixel wide and has a Y offset of 400 pixels. Therefore, the square's bottom edge will be positioned on top of the line because the square is 50 pixels inside. Now that we have this player object, we can call the draw method from the player class inside of the repeatedly invoked canvas function to get the player actually drawn onto the canvas, and we should be able to see it here. Now it is time to get the player jumping in the air so that it can actually avoid the obstacles. Now the actual jumping animation will last a total of 32 frames. I chose this number specifically because it is a nice even number that allows us to have the first 14 frames reserved for the player jumping up. The next 4 frames will have the player stationary in mid-air, and the last 14 frames will be for the player coming back down to the ground. So all in all, 14 plus 4 plus 14 again is equal to 32. The velocity applied to the square on its jump will be 12. This is a value that works well within the 32 frame limit. That is because it gets the player at an adequate height within 14 frames, but not too high. The jump height field will store its Y velocity needed for the jump, and it's 12 because of what I said before. The should jump boolean will determine whether or not the player square should jump or not, and the jump counter integer will increment on each frame of the jumping animation, allowing us to stop the animation when 32 frames are up. Now, this jump method will actually be called on every canvas frame. However, we cannot have the player jumping on each canvas frame. That is why we have nested all of the code inside of this parent if statement that will only be called when the should jump boolean is set to true, and it will soon be set to false again when the 32 frames assigned to the jumping animation are up, as is written here. We need to call the jump method before the player cube is drawn to the canvas. That way the jump can actually be seen visibly by the users. Now, in the completed application, the user was able to trigger a jumping animation by pressing the space key. We will create this event listener that will trigger its callback when any key has been pressed, as indicated by the fact that it says key down. And also notice how this event listener is not attached to anything. That is because it is an event listener on the window object, and in JavaScript we do not have to write out the window object when we are accessing properties and methods from it. It is all well and good to detect a key press, but we need to call a player jump on a spacebar key press specifically, so not just after any key has been pressed. That is why we create this if statement here. The code inside of it will only be called if the key that triggered the event callback was the spacebar. Notice that inside of it we have another if statement. We need this nested if statement to prevent the user from triggering another jump while the player is still in midair. So now if we go back to our application, we should be able to press the spacebar key, and as you can see, along with audio, it does move up in the air. Now that we had the basic jumping motion, it is time that we went one step further and got the square to rotate as it jumps. To do this, we will create 2 more fields in the player class. This spin field will store the current rotation of the player. Since the player is not rotated by default, we have set its initial value to be 0 to signify no rotation. This spin increment value returns a number that we can increment the square's rotation value by on each frame in the jumping process. It is 90 divided by 32 because we want to rotate the square by 90 degrees, and we want this rotation to be completed over the course of 32 frames. Now there is something that needs to be explained before we can continue with the rotation process. That is where canvas chooses to rotate from. By default, the canvas rotates in relation to its top left corner. This would be a problem for us because if we wanted to rotate the cube, then it wouldn't take much for the cube to be rotated off the canvas entirely. The solution is to work out the center point of the square and move the canvas origin to that point so that the cube can rotate properly in relation to its center without being thrown completely out of alignment. We will of course need to move the canvas back to its original position once we have rotated the cube, so that the canvas position is back to normal for other elements to be drawn onto. These 2 variables store the current x and y center points of the player square respectively. For reasons previously explained, we move the canvas before the rotation to the center point of the player. Then we move it back to where it was previously once the rotation has been completed. We multiply spin increment by these values because the rotate function takes in radians and not degrees. Radians are just an alternative measurement to degrees. All we are doing here is converting the degrees into radians. Lastly, we increment the spin by the value stored in spin increment. As said before, spin increment stores the current rotation of the player, and because we have just rotated it a bit, the spin increment value needs to be updated to reflect this new rotation. Now the problem that we have here is that the rotation will interfere with our jumping animation. This is because we are rotating the player square but are incrementing its y offset to make the player jump up at the same time. However, the latter will now no longer work because the player square needs to be fully unrotated in order for a boost to its y offset actually make the board go straight up. Because if it is rotated, then it will travel upwards, but at a tilt coming from the rotation and not straight upwards like it should without the rotation. To solve this, we are going to reverse the rotation of the player square after every frame of the player jumping has been drawn to the canvas. This means when the player is having its y offset increased, the player will be unrotated. However, by the time the player is being drawn to the canvas, it will be back in its rotated state. We can now rotate the player by the current value of spin before we rotate it by the spin increment. This is because when the code is called, the player should be unrotated entirely. However, this might be within mid-animation, and by this point the player may already be halfway rotated. We will therefore rotate the cube back to the rotation that it was on the previous frame, before adding some more rotation to the player to get it further rotated towards that 90-degree angle. As said before, we need a method that will unrotate the player as soon as its rotated form has been drawn to the canvas. As with before, we will translate the canvas to the center of the player square in order for the rotation, and then translate the canvas back once the rotation is over. To unrotate the player, we will rotate it back by whatever value the spin currently is, and then obviously the minus is how we do that. To get the player rotating as the jumping animation is being played, we call this rotation method to get the player rotating as the jumping animation is being played. It is very important that this counter rotation method is called after the fill rect method for reasons already stated. When the jumping animation is over, we still need to unrotate the player, but in addition to that, we will set the spin field back to 0. This resets the player rotation for a new jump to take place. It is important that this new jump starts from 0 and not some already rotated value. And so now we should have a completed rotation jump. As you can see, it's working. It rotates by 90 degrees on each time. So we can get the player to jump, we now need some obstacles for the player to jump over. Like with the player, the obstacles will have their own class to be instantiated from. Its coordinates are hard-coded to be just towards the right of the canvas edge and positioned on the y-axis, so they sit on the background line. We'll then be able to configure their size, although I will not actually be doing this in my version of the game. I will, however, be changing their speed. I want the obstacle's speed to increase the higher the player's score is. Like with the player class, we create this draw method that will render out the object onto the canvas with the current values. We will call this draw method inside of this slide method here. This means that the only method that we have to call repeatedly on each new canvas frame is this slide method, and not both of these methods. As you can see, all this slide method does is decrease the X offset of the obstacle so that it moves towards the left of the screen. Because we want to have multiple obstacles being rendered onto the canvas at the same time, we will create this currently empty array. Every time we want to spawn a new obstacle, we will push a new obstacle onto this array. And just so we can see what one of these obstacles look like, we will create this dummy obstacle inside of the array. For every canvas frame, we will loop through this array and render out every single avoid block object contained inside of it. And now if we go back, we should be able to see this dummy obstacle being rendered. Obviously we have to refresh just to see it, but it is there. We're now going to get rid of this dummy obstacle because it was only there for example. Now we want the obstacles to be spawned repeatedly over a random interval. Since we will be dealing with random numbers a lot, it is worthwhile to create this random number generated function. It takes in a min number and a max number of our choosing and will output a random integer that lies within both. This global variable stores the current average period that we have to wait for a new obstacle to be instantiated in milliseconds, so this translates to a second. There will of course be some variation added to this base number however. That's where the random element of our application comes in. As for this function, it takes in a length of time in milliseconds, and it uses math.random function so that we have a 50-50 chance of returning a higher length of time within a set boundary, or a lower length of time also within a set boundary that's based on the preset time global variable here. I won't go into the specifics of this function now. All I will say is that these values have been fine-tuned by me, and they seem to work well for this particular game. Now we want the speed of the obstacles to slowly get faster the longer the user survives. We will therefore create this variable. The starting obstacle speed will be set to 5 as you can see. When this function is called, we will push a new obstacle to the array so that it can be rendered to the canvas in the animate function. As said before, we need a way to repeatedly invoke this function so that we can spawn more than one obstacle. To do that, we will get the value from passing in the preset time global variable into the random interval function so that we can get a random variation of the preset time value. Then we will invoke this function again after that time has elapsed by using the setTimeout function. Of course we need a way of calling this function initially as it cannot call itself. For that we will call it once with this setTimeout function. Its delay value will also be generated from this random interval function. So now we should be able to see, okay, there's a bit of a glitch there, but essentially we should be able to see, as you can see, they are actually being spawned randomly. This is what we want. And obviously the game, it does on first glance appear to be playable. However, obviously we can't actually fail the game and we can't actually score any points. But before we do those things, however, there is a problem that we need to solve. It's not a disastrous problem, but it is just something that's worth pointing out so that we can save up on computer resources. That is the fact that there is no point having obstacles still in the array. Once they have gone over there, then we won't be seeing them again, therefore we don't really need them. To get rid of a specific item in an array, we will need to target it based on its index. To get access to the current index of the object in the array blocks array that is being looped through here, we include the second argument on the foreach's callback. This will be assigned to the index by default. This if condition is checking to see if the right side of the obstacle is less than or equal to 0. If it is, then we can safely remove it from the array by using the splice method. The one argument indicates that we only want to remove one object at the location stored in index. The code is in a setTimeout callback because if it wasn't, then the canvas would try to render out the obstacle at the same time that it is being removed from the array. This will cause a visual distortion. The set timeout function is the solution to this. It tells Canvas to wait until the next frame before doing the splice. Now we will actually begin to create a consequence for the user if they fail to avoid the obstacles. We will create this function. It will be used inside of the loop so that the collision detection can be checked on all of the obstacles. This long and convoluted code here is essentially just getting an exact copy of the class objects passed into the function. Noted that we were to just use the equal sign, then all we would be doing is copying a reference to the object, and not the object's data, which is what we are actually doing here. The reason why we are doing this is so we can modify some of the object's fields without making changes to the original object. As said before, we modify some of the values from the objects. We do this because when the square is rotated, it can get slightly longer on its size, and the collision detection function won't actually notice that the square has been rotated. The solution to this is to simply decrease the collision detection range by a few pixels. Now there is a way to get the function to take into account the rotated square, however it adds unnecessary complexity to our application, and if you really wanted to know it, then you could watch one of my previous tutorials on creating a physics engine in Canvas. There is also the fact that pixel perfect collision detection can actually make the player feel like the game's unfair, as it is being overly strict. This is definitely not the feel that we want our game to give off. We want to keep it feeling fun and loose. This function will return a boolean. The boolean will be true if a collision has taken place between an obstacle and the player. It is for this reason that we use the exclamation mark prefix on the return statement to invert whatever value is returned by the statement. This is because all of the conditions here check to see if the player is actually not colliding with the obstacle that is currently being checked, and you can read the comments here for more detail on that. We want the game to be paused completely if the user does mess up and hit an obstacle. To pause the game, we will actually need to assign the request animation frame method to a variable so that its value can be passed into another method. That method in question is this cancel animation frame method. As you can see, it will be called if this method returns a true boolean and the if condition is met, meaning a collision has occurred between the player and the array block that is currently being looped through. So if you play our game now, again, that's a glitch that can sometimes happen when you leave Canvas running in the background for a long time, and when the collision has occurred, the game is actually stopped and the sound effects plays. Obviously we haven't done the menu yet. As you can see, it's a completely static canvas now, we can't do anything with that. And as you can see, the collision section is looking good as well. Now, if you can punish the player for their mistake, then we should be able to reward the player for their success. We will create these two global variables. The first one is there to keep track of the basic score. The other one is there to check if our current score is a multiple of 10, and if it is, then we will increase the game speed. We will use this function to first convert the score into a string so that its value can be drawn onto the canvas. The purpose of this x offset variable is to position the score in the proper place when the score gains an extra digit. Currently it will be assigned to 0 because there is only one digit in score, as it is less than 10, and 0 multiplied by anything is obviously 0. To get this score to actually be displayed on the canvas, we will need to call it in the animate function like everything else that is drawn to the canvas. Another problem that needs solving is the problem of detecting when a player has passed over an obstacle without colliding into it. To ensure that the score is definitely recorded and not skipped over by the obstacle's fast speed, we will let the user score a point if the player square is within a range of pixels derived from the obstacle's current position. However, if we do this, then we need to prevent the user from scoring multiple points. We only want them to score a single point for avoiding a single obstacle. This is why we create this variable here. As soon as the user has scored a point, it will be set to false, meaning that the user can no longer score a point until the user jumps again, at which point it will be set back to true again. So we will add its true reassignment to the event listener, as just said. We will create this function. It will return true if the player square is within a range derived from the position of the obstacle that is currently being looped through. The function will return true if the centre of the square is greater than the first quarter of the width of the obstacle, but less than the last quarter width sector of the rectangle. So if the function is returning true, and the can score boolean is set to true, then we will do the necessary logic. Notice that we set the current time of the sound back to 0 before playing it again. This allows us to restart the sound from scratch if it is already midway through being played. So as said many times before, we want the game to get progressively harder the longer the user survives without falling. We'll now implement this functionality. So as you can see, the score is actually being displayed on the screen. And then, yeah, okay, so I don't know what went on there. Again, it's a glitch that I already mentioned. But as you can see, we are, and then, yeah. So obviously, as you saw the basics of the score being incremented. And what we need to do now is to make the game get progressively harder by speeding up the game when the user has scored so many points. In this function, we will see if the score increment value plus 10 is the same as score. This is how we know that score is a multiple of 10, because score increment will then be assigned to the value of score, if this is the case. Therefore, score increment's value will be the 10 times table. In addition to this, we will increment the value of enemy speed, so that all new obstacles will have a faster speed. To make sure that the game speeds up smoothly, we will also loop through the existing obstacles in the array blocks array and change their speed to match the new value of enemy speed. As said before, not only do we want the speed of the obstacles to be increased, we also want the average time before obstacle creation to also be decreased. The way that we do this is interesting. We use a ternary operator to check if the preset time is greater than 100 or equal to it. If it is, then we will subtract 100 by its value. If it isn't, then we will assign it half of what it was previously. This is of course to prevent the game from going into minus numbers. This function will need to be called in the animate function, because the player can score at any point in the game. So I don't really know if I can demonstrate it now, but rest assured it does actually speed up when we get to 10. So we'll just see actually. Might as well just give it a go. But obviously it's going to be a bit hard on my behalf because I have to not fail, which to be honest I'm not the best at this game. And one more. And yeah, as you can see, clearly it speeds up and that's all we need to see. What we need to do now is to get that main menu to show up on game over. So to do this we'll actually go back to our markup file. As you can see, the restart game method will be called when we click on the button. We have obviously not created this function yet. It is also important to notice that this 0 text that we have used as a placeholder for the amount scored is in its own span element. We will soon be updating this text with the real user score. And obviously, you know, it's just displayed there because it doesn't have any styling, so we need to actually give it some styling. So here is the styling for the overlay ID. Here is the styling for the card ID inside the overlay ID. Here is the styling for the paragraph element inside the card ID. And here is the styling for the button inside the card ID. Now it is worth mentioning that all this overlay section does is give us an absolute position element that matches the entire height and width of the viewport. It is set to be display flexbox, allowing us to center the actual menu as created with this card element in the middle of the screen. And we should be able to see, as you can see, whoops, this is what it looks like. There isn't actually any text displayed in the button, so we will just say restart, question mark, and then we should have the text there. Scrolling down, as you can see, we've actually assigned an animation to this card element. This animation is what will fade the menu into existence when the user triggers the game over. Also, it is worth mentioning that we are actually going to set its display to be none. So now if we go back to application, the menu's completely disappeared. This is because we don't actually want to see it until the user triggers the game over. So the animation that I just talked about will look like this. Now in order for us to be able to interact with the card and the card score span element, which contain the number we need to assign the score to, we must first create references to these two things. So when the game is over, we will change the display to block, which will simultaneously trigger the animation as well as assigning the card score span element to the current score. We will then get the game to restart by initializing all of the global variables that we have used throughout the application to their default values that they had on game start. This will be done in a function that will be called when we press the button to indicate that we want to restart the game. As for that function, we will create it now. So the card menu is made invisible again, and the animate function will be repeatedly invoked again. The reason why the blur method is used on the button is because we don't want the button to be able to be triggered on a press of the spacebar, and if we do not blur out the button after the user clicks on it, they will be able to press on the button using the spacebar because it's already been selected and it hasn't been deselected with the blur method, which is what we use the blur method for. And so here it is. Here is the finished application, and everything's working fine, as I've already tested anyway. If you had any problems throughout this tutorial, then the code pen to this application will be posted in the link of the description box of this video. And you can also post any questions that you might have in the comments box of this video, and I will answer them to the best of my ability. I would also be very happy to hear from you, and I would also be hugely appreciative if you like to subscribe to this video. You'll be doing me a huge favour if you did that. And I hope you learned something from this video, I hope you benefited from it, and I hope you enjoyed it, and peace out.